When dealing with high amperage applications like tanning beds, finding a compact and recessed service disconnect can be challenging. Here are some options to consider. Firstly, recessed panel disconnects offer a solution where space is limited. One example is the Hubble Quick Connect Quick Disconnect panel. This features a flush-mounted, low-profile design with a 400 amp capacity and a rocker-type safety switch. Secondly, the Eaton PowerCloud 2 panel presents a compact panel with a recessed door and current ratings up to 225 amps. Thirdly, the Schneider Electric Square DQO panel provides a low-profile panel with a flush-mounted door and various circuit breaker options. When selecting a recessed panel disconnect, ensure it meets the required current rating, consider the available space within the recessed area, and ensure it is easily accessible for servicing. The NEC, specifically Article 408, covers switchboards, switchgear, and panel boards. Another alternative is to consider compact disconnection solutions. A circuit breaker fuse box, often DIN mounted, offers a compact design with ratings up to 80 amps. Secondly, industrial-grade plugs and receptacles designed for high amperage applications can offer a lower profile than traditional pin and sleeve connectors. Thirdly, split bolt connectors can provide a secure and compact connection for high amperage applications and can be recessed into a junction box for a lower profile. When selecting a disconnect or solution, there are several factors to keep in mind. Ensure the selected disconnect or solution meets the required current rating of the tanning beds, which in this case is 80 amps. Carefully consider the available space within the recessed area to ensure the chosen solution fits properly. The disconnect or solution should be easily accessible for servicing and maintenance. Always consult with a qualified electrician to determine the most suitable solution for the specific application and local electrical codes. Regarding the 2017 NEC, Article 408 addresses requirements for switchboards, switchgear, and panel boards, which are relevant to selecting and installing a service disconnect. Also refer to Article 230.70, which covers the location of disconnecting mains. Section 230.70. 8.1 states that the disconnecting main shall be installed at a readily accessible location either outside of a building or structure or inside nearest the point of entrance of the service conductors. This may influence the choice of a recessed versus non-recessed solution depending on the specific installation scenario. Ensure that the selected components are appropriately rated for the voltage, which is 208 volts in this case. Additionally, consider the interrupting rating of circuit breakers or fuses to ensure they can safely interrupt the available fault current at the installation location as outlined in Article 110.9 and 110.10. When working with three-phase systems, proper phase balancing and conductor sizing, as per Article 310, are crucial to ensure safe and efficient operation. Also, consider the ambient temperature and earthing factors for conductors as specified in NEC Table 310.15. B1 and related tables. For example, if the ambient temperature exceeds 30 degrees Celsius, the ampacity of the conductors must be directed according to the correction factors provided in the tables. Furthermore, ensure all electrical work complies with applicable local codes and regulations, and that all components are listed or labeled for their intended use. Branding and bonding, as detailed in Article 250, are crucial for electrical safety. Ensure proper grounding electrode system is installed and that all metallic enclosures and equipment are properly bonded to the grounding system. When using a recessed disconnect, pay attention to the working clearances around the equipment, as required by Article 110.26. Sufficient space must be maintained to allow safe access for maintenance and operation of the disconnect. When selecting a service disconnect, consider the short circuit current rating or SCCR of the equipment. The SCCR must be equal to or greater than the available fault current at the point of installation. This is crucial for preventing equipment failure or hazards during a short circuit event, as detailed in Article 110.10. For equipment containing overcurrent protective devices, such as circuit breakers or fuses, verify that the interrupting rating of these devices is sufficient for the available fault current. The interrupting rating is the maximum current that the device can safely interrupt without failing or causing damage. The NEC requires that the interrupting rating be clearly marked on the overcurrent protective device. Remember to consider the environmental conditions when selecting a disconnect. If the installation is in a damp or wet location, use equipment that is rated for those conditions, such as NEMA 3R or NEMA 4 enclosures. Consider using a disconnect switch with a visible blade to provide a clear indication of whether the circuit is open or closed. A visible blade disconnect can enhance safety during maintenance and troubleshooting. When using plugs and receptacles for disconnecting means, ensure they are horsepower rated for the connected load. Horsepower ratings indicate the capability of the device to safely interrupt the starting current of motors or other inductive loads. Carefully select the appropriate size and type of conductors for the application, considering the ampacity, voltage drop, and environmental conditions. Use the NEC tables in Article 310 to determine the appropriate conductor size for the load. When installing conductors and conduit, follow the full requirements in Chapter 9 of the NEC to ensure proper heat dissipation and avoid overheating. Consider using surge protective devices or SPD to protect sensitive electronic equipment from voltage surges caused by lightning or other transient events. SPD should be installed in accordance with Article 285 of the NEC. When making connections, use appropriate connectors and terminations that are listed for the conductor size and type. Ensure that all connections are properly tightened to prevent loose connections, which can cause overheating and electrical hazards. Consider using arc flash hazard analysis to determine the potential arc flash risk at the installation location. Based on the results of the analysis, implement appropriate safety measures, such as using personal protective equipment or PP to protect workers from arc flash hazards. Properly label all disconnects and electrical panels to indicate the circuits they control and the voltage and amperage ratings. Clear labeling helps to prevent confusion and promote safety during maintenance and troubleshooting. Always follow the manufacturer's instructions for installation, operation, and maintenance of electrical equipment. The manufacturer's instructions provide valuable information about the proper use and limitations of the equipment. When replacing electrical components, use components that are of the same type and rating as the original components. Using incompatible components can create safety hazards or equipment malfunctions. Conduct regular inspections and maintenance of electrical equipment to identify and correct any problems before they cause failures or hazards. A well-maintained electrical system is a safe and reliable electrical system. In summary, selecting a compact and recessed service disconnect for high amperage applications requires careful consideration of several factors, including current rating, available space, accessibility, and compliance with electrical codes and standards. Consulting with a qualified electrician is essential to ensure a safe and reliable installation. Be aware of potential issues like voltage drop, harmonics, and electromagnetic interference, and take steps to mitigate these problems if necessary. When planning the electrical system, consider future expansion or changes in load requirements. Design a system with sufficient capacity and flexibility to accommodate future needs. The layout of the electrical system should be designed to minimize voltage drop and ensure that all equipment receives adequate voltage. Long conductor runs can cause voltage drop, which can affect the performance of equipment. Consider using larger conductors or increasing the voltage to reduce voltage drop. Harmonics are distortion of the sinusoidal waveform of alternating current or AC voltage. Harmonics can cause overheating of equipment, increased energy losses, and interference with electronic devices. Consider using harmonic filters or other mitigation techniques to reduce harmonic distortion. Electromagnetic interference, or EMI, is the disturbance caused by electromagnetic fields from electrical equipment. EMI can interfere with the operation of electronic devices and communication systems. Consider using shielding, filtering, or grounding techniques to reduce EMI. Energy efficiency is an important consideration when designing an electrical system. Use energy-efficient equipment and lighting, and implement energy management strategies to reduce energy consumption. Electrical safety should always be the top priority when designing, installing, and maintaining an electrical system. Follow all applicable codes and standards, and use qualified electricians to perform electrical work. Proper coordination of overcurrent protective devices, such as circuit breakers and fuses, is essential for ensuring electrical system safety and reliability. Selective coordination means that only the overcurrent device closest to the fault will open, minimizing the impact on the rest of the system. When working with 208-volt systems, be aware of the potential for ground faults. Ground faults can occur when a live conductor comes into contact with a grounded surface. Ground fault protection devices, such as ground fault circuit interrupters or GFCIs, can help to prevent electrical shock and fires caused by ground faults. When installing electrical equipment in hazardous locations, such as areas with flammable gases or dust, use equipment that is specifically designed and rated for those locations. Hazardous location equipment is designed to prevent explosions or fires caused by electrical sparks or heat. When working with renewable energy systems such as solar or wind power, follow the specific requirements for those systems in the NEC. Renewable energy systems can present unique challenges for electrical safety and performance. Consider using power quality monitoring equipment to track the performance of the electrical system and identify any potential problems. Power quality monitoring can help to prevent equipment failures and improve energy efficiency. When designing an electrical system for a commercial building, consider the needs of the tenants and occupants. The electrical system should be designed to provide adequate power and lighting for the intended use of the building. Finally, always remember that electrical work can be dangerous. Take all necessary precautions to protect yourself from electrical shock and other hazards. Work safely and follow all applicable codes and standards. Consider the use of solid-state relays or SSR for switching applications. SSR are electronic devices that can switch AC or DC loads without using mechanical contacts. SSR offers several advantages over mechanical relays, including faster switching speeds, longer lifespan, and reduced noise. Also, consider the use of variable frequency drives or VFD for controlling the speed of electric motors. VFD can save energy by reducing the speed of motors when they are not needed to operate at full speed. Consider using power factor correction capacitors to improve the power factor of the electrical system. A low power factor can increase energy losses and reduce the capacity of the electrical system. Consider using LED lighting fixtures to reduce energy consumption and improve lighting quality. LED lighting fixtures are more energy efficient and have a longer lifespan than traditional lighting fixtures. Furthermore, consider using occupancy sensors to control lighting in unoccupied areas. Occupancy sensors can automatically turn off the lights when no one is present, saving energy. Also, consider using daylight harvesting systems to reduce the use of artificial lighting during the day. Daylight harvesting systems use sensors to detect the amount of natural light available and adjust the artificial lighting accordingly. Always consider the impact of the electrical system on the environment. Use sustainable materials and practices whenever possible to reduce the environmental footprint of the electrical system. Dispose of electrical waste properly and recycle materials whenever possible. Finally, continue to learn about new electrical technologies and best practices to stay up to date on the latest developments in the field. Continuing education is essential for maintaining competence and providing safe and reliable electrical services.